Hi guys, I shouldn't really be saying guys, this video is kind of directly for Variac or Carl Bishop actually, Carl Bishop and Variac Maniac. So this is a small schematic, or schematic I should say, of what happened. A lot of people want, sorry I just have to open a window, it's bloody hot up here. So what happened about this short circuit problem that I had wasn't really a problem, it was intentionally done for some stupid reason. So this is me, that's a short circuit, that's a socket. These are all the fuses so these are all the fuses so up to this outlet, these are all the fuses that are protecting this outlet right here. And what blew was the power pole fuse all the way up there. So the house that I did it in has a three-phase input, phase A, B, and C, 1, 2, and 3, and this is the meter board. As you can see, 3 fuses for 100 amp meter board fuses, as it says there. They're all 100 amps. The pole ones are 60s. And that one was blowing, as you can see. Sorry, my handwriting isn't the best, but could get that better. This is the main fuse for the subboard. So that outlet, there was a main switchboard, then a subboard. Like it's basically a subboard is let me draw it for you. Here's a stupid pen. Main switchboard, yes. Lights, sockets, whatever. Sockets, range, right there, blah blah blah. And on one fuse, sub. And that wire goes from out there down to a little board. There's a whole lot of other fuses. Stupid pen. So this would mainly be, I don't know, sockets, lights, and other miscellaneous crap. Mainly sockets and lights they're used for. So basically the house, this is a very big house, it's my grandparents' place, is one switchboard, main switchboard for the whole house, and it is a subboard. So and that subboard feeds some stuff downstairs where I was doing the, I should say, experiment. And that subboard had a 20 amp breaker feeding the socket. And protecting that subboard was a 30 amp fuse up on the main board. So as I said before, here we go, sorry it's very bad, but the sub, that was 30 amp. Down there where I did this experiment, should write it actually, 30 and 20. And that didn't blow. Well, it did blow first, and actually, I'll tell you what happened. Did it once, yep, cool, and then it blew, then did it again. It didn't blow, it actually blew the power pole fuse this time. So it blew the breaker once, I reset it, and I joined the wires together again, and it went bang, and it was a very stupid experiment. It's not really an experiment, it was just pure stupidity. So that's what happened. 20 amp, no, didn't blow. 30 amp protecting the main subboard, no, that didn't blow. But it was more of an instant. So I had short circuited once, the breaker went for the socket, and the blah blah blah, yep, and then I did it again, and it was an instant out, instantaneous blow. It, like, the pole fuse didn't blow on the first one, it blew on the second short circuit attempt. So I shorted out once, the lights dimmed, they dimmed like instantly, but the breaker tripped. So as you know, and then I short circuited again, and all the lights went out. And then, yeah, and then shit happened and crap. And so yeah, back up to the main meter board here. The meter, it's basically, the house is in two flats, the top flat and the bottom flat. The bottom flat's just a really small flat. The top flat isn't really a flat, it's more like a house. So two phases are going into there. One is going to, yeah, where the main board and where I'm playing around. The other one is going to some other heating miscellaneous stuff. And the other one is going to flat B, should I say. So that's all fine. So what had happened there is only one fuse blew out, because it wasn't a phase-to-phase short, it was a phase-to-neutral short. So that fuse blew out up there on the pole. This fuse was fine here, and that fuse was fine, but the house did not have any power to it, because I think the meter has a relay inside it that if one phase goes out, it drops out everything else. But this guy here on flat B is on a different meter, and flat A, where I was in, had two phases going into the meter, so it just dropped out the other one, because when the electrician came, he tested the phases. One was out and one was still going, and the other one was going to the old man, or the flat B, I should say. So good, bad, shed itself. Good. Meter wasn't happy because that went fully out. If it was just a traditional meter, I'm pretty sure it would have kept phase B going for me. So in that case, if it was a traditional meter, that's why I don't like smart meters. But I guess why the smart meter did that is usually when you have one phase, when you have one or more phase, when you have phases going, when you have when you have three or two phases going, when one phase drops out, it's I think it's involved with motors that gets all unbalanced, and that's not very good for the grid, I should say. Apparently it's just involved with balancing the phases being balanced out. So when you're doing three-phase work, if you gotta balance out each phase, you can't have really one phase unbalanced, because it's not the best. So but yeah, since the flat B, flat A where I was in actually requires two phases, because the heating there, all the heating is underfloor, and there's like multiple underfloor heating circuits. So if you put underfloor heating and sockets and lights on one phase, it wouldn't be able to cope. It would just be overloading all the time, and fuses would be blowing, and things would just get a bit hot, I should say. So yeah, I'm not talking about what happened, but that's why the flat A has two phases. So yeah, that's what happened. No other fuses went, because when I went back to the room where I did the short circuit, the lights were still going, the socket even was still going, everything was still going, and the electrician checked that everything was okay, because after a short circuit some things may not be too happy, but the electrician checked that, and that's okay. But yeah, he told me none of the meter board fuses were blowing, so yeah, so we called a lineman, and the lineman came along, replaced it, and went back to do other jobs that he had to do at 2 o'clock in the morning. Anyway, that's the controversy of what happened. I hope you guys understand. If you have any questions, just ask me in the comments, and I'll be happy to tell you. But keep out of the personal side. Just ask me about what fuses and blah 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 blah. And yes, everything's fine. Everything was done by, and I don't do house wiring. Well, it's a bit windy. I don't do house wiring. That's for an electrician. I only do little projects that I like to do. That's not really permanently connected into the house. because New Zealand laws are very strict about doing electrical work. The only electrical work I can really do legally is this type of stuff. Put a plug on stuff, put a plug on a cord, but you have to like comply to standards and the blah 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 blah. So yeah, I could put a new plug on it. That's all I could do. But I can't be. Like, I'm still building the switchboard. Actually, it's actually coming. Yeah, you guys seen the video of the switchboard coming together. I can do that. Like, it's not permanent. It's not gonna. It may be hung up on the wall, but it's an electrical appliance. But oh well, it's my project. That will be checked by an electrician because I know a few of them. So anyway, that's what happened. So for Carl Bishop and Variac Maniac, and maybe other people who want to know about that, be nice in the comments if that's okay. And yeah, any more questions, just ask me in the comments. But yeah, you can ask me what happened and blah 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 blah. But yeah, this is all you guys really need to know: is the power pole fuse blew, the house went out, and yeah, my grandma was not happy. Anyway, that's it for today. Until next time, thank you for watching.